hope this is recording. I guess we'll find out. All right, welcome to your last lesson of Chapter 6. Today we're going to deal with systems of linear inequalities. So instead of just one linear function, you're going to see two on the same graph. So this is just an example of what it might look like. You can see we have two lines. One is solid, one is dotted. And the one thing I kind of want to point out is we end up with 1, 2, 3, 4, most of the time, 4 sections when we have two lines that intersect. And so one of these sections is going to be the solution set. What you can tell from the dotted line is that we have shaded below the dotted line because we're not shading up above it at all. And from the solid line, you can tell that we shaded above the solid line. So you can see that we have this one section right here. All these ordered pairs are a solution to both lines, and that is our solution set. All right, so tell whether the ordered pair is a solution of the system of inequalities. So we did this with just one inequality. When you have a system, you're just going to plug your ordered pair. You have your x and your y into both of the inequalities. So first we have y is greater than 3x. And so we're just going to plug in those values. Our y is a 0, so 0 is greater than 3 times. We're going to plug in a 1 for the x. We have 0 is greater than 3 times 1 is 3. Is that true or false? Is 0 greater than 3? That is a false statement. We're going to also plug our ordered pair into the other inequality. Y is less than or equal to x minus 2. So our y again is a 0, is less than or equal to our x is a 1 minus 2. Is 0 less than or equal to 1 minus 2 is negative 1. Is 0 less than or equal to negative 1? That is also a false statement. So when the ordered pair is a solution, you're going to get a yes. It's going to work in one inequality and it has to work in the other. If you get at least one false statement showing up, then no, it is not a solution to the entire system. I like to plug it into both just to double check, maybe double check my work, but you do have to get a true and a true to say yes on this one. Alright, so now we're just going to practice graphing. You do want to solve for y when necessary. Our first inequality, y is greater than negative 2/3 x plus 1. So I'm going to identify negative 2/3 is our slope, and this 1 is our y-intercept at 0, 1. So I can go ahead and put that on the graph. So here's my y-intercept, slope is negative 2/3, so down 2 to the right 3, down 2 to the right 3. And then I'm going to take a look at the inequality to see if this should be a solid or dotted line. So it says greater than, it doesn't have that or equal to line, so I know that this will be dotted. So I'm going to draw in the dotted line. Alright, so in our last lesson, we would go ahead and do our shading next. What I like to do is use arrows to indicate where the shading would be. So when it's greater than, that means we will shade above. So I'm going to go to my y-intercept, I'm going to put an arrow above, and I'm just going to do this along the whole line, and what I do then is save the shading for the very end once I get both lines. But I know that the shading is going to be above that line somewhere. Alright, so our next inequality is x is greater than negative 2. This is one of our special lines. It's either going to be horizontal or vertical when you have just one variable. So we go to the x-axis at negative 2, which is right here. We want to draw the line that crosses through the axis, so that's going to be a vertical line. Solid or dotted, this was going to be a dotted line just like the other one because it doesn't have the or equal to. And then again for the shading, I'm just going to put arrows to indicate where the shading is going to go at the end. So x is greater than negative 2. So this is your one special line where you can't go above or below because it's perfectly vertical. You have to go right or left. So which side has greater x's than negative 2, the left or the right? And we can see that if we go to our intercept to the right, that's where the numbers get bigger for your x's. Okay, so we have two lines. We do have those 4 sections that got formed when we had 2 intersecting lines. So of the 4 sections, we want to graph just one of those. And we want to find the one, that has both sets of arrows pointing in. I'm sorry, while I'm talking to you, I'm trying to find my highlighter here a second. There we go. Okay, so we can see that this section right here has both the blue arrows and the green arrows pointing in. So this is going to be our solution set, this section right here. What that means is that every single ordered pair that we just highlighted will be a solution to both inequalities. You could plug it in and get a true statement for both. If I were to choose an ordered pair from anywhere else on the graph and plug it in, you would have a false statement. You might get a true and a false when you plug into both, but remember, if just one false shows up, then it's not a solution to the entire system. So we are shading the solution set for the whole system. That's where both arrows point in.